Good morning, everyone. We're going to go ahead and get started with our leachate management workshop. Thank you for joining today. This workshop is made possible between Ohio EPA and the Ohio Environmental Health Association. This workshop is being recorded and will be made available to participants at a later date. We did go through the process and get this training approved for 2 registered sanitarian credits. If you want to receive credits for this workshop, we ask that you please verify your attendance. When you log in, it does capture your name and email address, but we all know sometimes things don't go as according to plan. So if you could just enter your name and your RS number in the live events question and answers, we will use that to mark you as attending. If you have problems with that, please feel free to email myself or Jeff Monavon. He will have that information in the Q&A for you to get. All participants are already muted in this workshop, so you don't have the ability to speak verbally, but please feel free to use the Q&As as a way to communicate with us if you have a question, or you want to post something for maybe a topic on the next workshop we do. All presentations today will have question and answers as time allows. You're always we encourage you to submit your questions during the presentation as they come up. And if you have something afterwards, always feel free to send it in and we'll work to get you an answer even if the workshop has ended. So to jump into a little more towards the workshop, I want to recognize our collaborators today. The first one is the Ohio Environmental Health Association. They work with us on creating topics that are relevant to the solid and infectious waste and construction and demolition debris world and things that our inspectors, whether they're at the Ohio EPA or a local health department, may encounter. We also get recommendations from the Health Department Advisory Panel, which is a advisory panel through the Division of Materials and Waste Management. We have a couple small little updates for the Division of Materials and Waste Management. We recently had a new assistant, a chief named Joe Gokachea. Quite a few of you know him. You will start seeing him around things a little more often. We are still somewhat working remotely. We have started phasing some things back in. You will see, your inspectors out doing inspections, assisting health department. All of those normal activities have resumed. Mid-November, Ohio EPA is launching the mosquito control grant application. We plan to open it around November 18th. We will also be doing an In Your Community webinar to start off our grant cycle. Jeff's going to post that information if you're interested in the chat. Not a lot change to the grant cycle, but it's always, beneficial to listen in for a little bit, and that presentation will be made available afterwards in case you can't attend. And I think I've covered my update, so I'm going to turn it over briefly to Steve Ruckman with OEHA.
Thank you. Good morning, everybody. I wanted to just give a couple updates on some training opportunities that are going to be offered through the Ohio Environmental Health Association in October. We have our district fall educational conferences in 3 of our districts this year. The first being the Southwest District Fall Conference, which will happen October 6th and 7th at Sinclair College. The second is the Northeast District Fall Conference. That's October 12th and 13th. It's going to be happening at the Hilton Garden Inn in Twinsburg. And then finally, the Northwest District Fall Conference will be October 14th and 15th at Kalahari and Sandusky. For more information on these conferences, you can go to our website which is www.ohioeha.org. And there will be opportunities at all of those conferences for a registered environmental health specialist to receive continuing education credits and learn about various different topics in environmental health. Other than that, our board continues to monitor legislation which may impact registered environmental health specialists in Ohio. Probably the one thing that many of you have seen are the vaccine and face mask requirement bills that are going through the General Assembly. Seems to be, I guess, the hot topic of today. And we're monitoring those for our membership and any impacts that that may have at the local health department level. Other than that, that's what we have going on for the fall. And I welcome any questions, or if you have something that comes up, you can always shoot me an email or any of our district directors an email, and we will get back to you on that. And all of our contact information is also available on our website. Thank you very much.
Great, thank you, Steve. Next, we will move to Nikki Lemon, who is with the Franklin County Public Health. She is also the president of the Health Department Advisory Panel. Nikki?
Thank you, Leanne. Good morning, everyone. I'm going to just give a brief overview of the Health Department Advisory Panel. This panel was started to create a stronger relationship between the Ohio EPA Division of Material Waste Management and approved health departments. The panel provides input to assist local health departments related to solid and infectious waste, and also construction and demolition debris programs. The Health Department Advisory Panel helps Ohio EPA DMWIM learn how to better assist health departments throughout the state in various aspects related to programs such as information sharing, training, and relationship building. The HDAP is made up of 13 members. It is a voluntary panel, and we meet quarterly. These meetings are open to all approved health departments throughout the state. So if you would like more information, the EPA will be emailing meeting details and log information early next week, but please reach out either to myself or Jeff Montavon or Leanne, and we can get you some more information. It's been a pleasure serving on the panel, and I hope you all enjoy this workshop today. Thank you, Leanne.
Thanks, Nikki. Also, for anyone who's interested in attending the next meeting, like Nikki said, we're going to be sending out information soon. But I want to also put it out there that that meeting will have a brief overview of the e-business center as it relates to licensing, because we know that for anyone who has a licensable facility in their jurisdiction, the deadline for license applications is tomorrow, and then all the fun stuff starts after that to get these licenses out by the end of the year. The presentation will be by me and Brian Durth. If you aren't able to make it, Brian and I are always available to help with eBiz and any problems you may run into. Now back to our workshop. Just a quick reminder again, we are having people send us their names and RS numbers as they have the time, whether it's in the live Q&A or if it's by an email to me or Jeff. We just do this as a verification that we have you logged in, because we know if you're going to join our presentation and you're an RS, you would like to get those credits. We also are going to do certificates of attendance. It will take us about a week or two to get those out, but based on feedback from our previous workshops, we know that's something that people would like to see, so we are going to put our best effort forward to get those out as quick as we can. And of course, if you have questions or you don't see your certificate come through, please feel free to reach out to us at any time. We're glad to help you. So moving on to our first presentation. It will be by Brian Queen, and it will be an engineer design of leachate management systems. Brian is our lead environmental specialist with Ohio EPA's Division of Materials and Waste Management and our Southeast District office located in Logan. Okay, Brian, we're ready.
So I'm going to discuss with you leachate management system design, and the topics I'll cover are leachate generation, collection, system design, sump design, leachate conveyance system, and leachate storage system. So here we have a typical landfill. In this area, the landfill is covered with transitional cover and intermediate cover, and this is the phase where they're currently taking waste, and here's the active working phase. When rain comes down and falls under the transitional cover, most of it flows down the slope into surface water channels and onto the sedimentation pond. Everything that doesn't flow off seeps into the transitional cover. Some of that is absorbed by the plants and evapotranspirated. The rest of it seeps down through the waste into the leachate collection system, where it flows out of the landfill to the tanks. Very similar for the intermediate cover, and for the active working phase, if everything's working correctly, rain just soaks straight into the waste and to the leachate collection system. If we look at the design of the bottom of the landfill, the slope of the leachate collection system, in this case, this is an old phase, so the leachate would flow down through the phase, out through the toe of the facility, through a leachate pipe, and on to the leachate tanks. In the more modern portion of the facility, the leachate flows through the system to a sump, to a riser pipe, through a force main, and then to leachate collection tanks. If we zoom in a bit onto this cell here, we can see the topographic lines that indicate the elevations of the floor of the landfill. And we can see this elevation here is 840 feet, 838 feet, and so on. So it slopes down in this general direction towards the leachate collection pipe, down the leachate collection pipe to the sump, from where it can be pumped out to the leachate collection tanks. If we look at this facility in cross section at the point in time where there's 10 feet of waste in the cell, we can examine one of the key design components to leachate collection system, and that's something that's called head-on liner. So if you think about head-on liner, it's basically the height that leachate fills up the landfill in comparison to the height of the drainage layer and the height of the waste. In this example here, you can see that there's a small hole in the HDPE liner, and there's a small amount of head on top of the liner system, and that hole would be leaking very slowly, much less than a gallon a minute. If there was an increased amount of head, more leachate would be leaking through that hole. And as you can imagine, the higher the head gets, the higher the pressure gets, and the more leachate can flow through that hole. So in design, US EPA has limited the allowable head in a landfill in design to be 1 foot. So when designers are designing the landfill system, that's one of the key things they focus on when they're designing the facility. The way they determine whether or not the facility maintains that less than a foot of head requirement is they use a computer program that's the HELP model. It was developed by the Army Corps of Engineers for US EPA back in the early 90s. And it's been rewritten a few times since then. It's a fairly simple program, but it gets the job done. When you're using that program, the main inputs that you put into the program is the maximum flow length that the leachate flows, the landfill cross section that you're designing under, the permeability and slope of the drainage layer. So those are the key things that you look at using the HELP model and designing the landfill's leachate collection system. If we look back on this phase and we notice this area over here, leachate would flow roughly that distance. And as you look, the further downslope we go, the longer the distance goes until we get to this point here. And at this point here, the length is 648 feet, which, to be honest, is a very long length when we're talking leachate collection systems. So this facility had to be very careful in their design and their selection of leachate collection drainage layer material. So looking at this specific facility, the design scenario that Ohio EPA recommends when designers are trying to figure out what permeability to set their drainage layer at is a daily cover being placed in cross section, 10 feet of waste, and then the drainage layer and the liner components. So in the situation where the designer is trying to determine whether sand is appropriate for that drainage layer, they'd feed all this information in the HELP model, and the HELP model would generate the calculated head on the liner system. And with sand at 10 to the negative second centimeter per permeability, which basically means that a drop of leachate would flow at a velocity of 0.01 centimeters per second flowing through that sand, which is fairly slow, but it's substantially faster than it would flow through the clay liner, which would be more like 10 to the negative second permeability. So if we did this calculation in the HELP model would tell us that it would end up with 12 feet of head on top of the liner system, which it does not meet the design requirement, which would indicate to the designer that sand is not an appropriate drainage layer at this facility. So if they did basically the same calculation, but they changed the permeability of the drainage layer to a permeability more similar to gravel, which would have 1 centimeter per second permeability or greater, and they did the calculations, they would find out that the predicted head on the liner system would be about 11 inches, which would be acceptable design because it would meet the 12 inches of head requirement. And that's exactly what this facility has in their design. They have a design minimum permeability for their gravel drainage layer at 1 centimeter per second. So how do we get leachate out of a landfill? There's basically two different methods, and the landfill that I'm using in my example actually has both. You can drain leachate by gravity out through the liner system of the landfill to a lift station, then to a tank, and then it can either go to a sewer or it can be hauled by truck to a treatment plant. The other option is to basically pump the leachate out of the facility. If we look at a cross section where leachate's leaving the facility via gravity, so this image represents the liner system and drainage layer of the landfill. Your waste would go in this area. So we have the leachate collection pipe sloping down and then penetrating the side of the landfill and going out to the lift station and eventually to the tank. At this penetration, there's a boot that keeps the leachate from leaking out of the facility. And here's a basic image of what a lift station looks like. Often they're constructed out of concrete and they're lined with H2PE liners similar to a landfill. And within that lift station, there are 3 floats, the bottom float being the pump off, then pump on, and the high level alarm float. From the lift station, leachate gets pumped up through a pipe and into the leachate collection tank. how these systems work is leachate as it flows into the system goes up, hits the the middle pump on float, and that turns on the pump and the leachate is pumped out into the tank. If this system isn't working correctly and the pump is broke, leachate flows in from the landfill, floats the upper high level alarm, and sets off the alarm, indicating to the operator that they need to come out and fix the pump in the lift station. If we go back to our phase in the more modern portion of the landfill, we can see that the sump for the facility is at the end of the leachate collection pipe. It's basically that little square that you see down there, and here's the riser pipe and then the force main. And here's that sump in cross section. We can see that it's a lower area with larger gravel, and within that there's a pump and a pressure transducer that turns the pump on and off. And if we follow the plumbing and the wiring up the riser pipe, we end up at the lift station, the leachate sump panel. And here in the background, we can see where the riser pipe comes in and is plumbed in. On this leachate sump panel, we can see the high level alarm and the leachate depth readout. If we zoom in a bit, we can see the current depth in the sump is about 26 inches. Excuse me. And that means that in the sump itself, there is about 26 inches of leachate. And at this facility, the pump is just about ready to turn on and pump leachate out. If we look back to our cross section, the basic way the system works is leachate flows into the sump. It gradually fills the sump, and eventually the pump turns on and pumps the leachate out. And this happens multiple times a day, every day, and the system works just fine. And obviously, on occasion, the pumps do break down, and when that happens, the leachate begins to build up on top of the sump, and eventually the high level alarm would go off on the sump. Our regulations state that the high level alarm needs to go off at least at 1 foot above the top of the sump. Often operators have it set at a lower elevation so they can come in and fix the pump sooner. And the top of the sump is considered basically this grade break right here. So this would be your normal landfill cell. This would be the sump, and then this would be the top of the sump itself. Now looking at the leachate conveyance system. So we go from the pump to the riser, out from the riser to the force main, and then all the way down to the leachate collection tanks. Here are some of the typical leachate collection tank designs. What you see most often is a single walled tank within a secondary containment system. That secondary containment has to be able to contain at least 110% of the volume of the larger tank within the containment system. Another common tank design is a double-walled tank, both above ground double-walled tank and underground double-walled tank. Both of these tanks are a tank within a tank. So there's a tank that holds leachate, and then there's a tank that holds an air gap and the inside tank. So the way they're supposed to work is there's always air between the two tanks, and there is a witness zone in there where and a witness where you can either look through or there's a pressure transducer inside that space between the two tanks, so we can find out if there is leachate between the two tanks, which there's never supposed to be leachate between the two tanks. It's always supposed to be dry. But if there's a hole in the inside tank, we'd find leachate between the two tanks. Good thing for you to check up if you have a site with a double-walled tank. Ask your operators how they know, or can they show you if there's any leachate between the two tanks. From these tanks, the leachate can either flow to a sewer, or at some facilities it actually flows to the sewer from the landfill. And at a lot of facilities, it's actually trucked off instead of piped directly to a sewer. So here's an image of a tank at an actual landfill. We can see the secondary containment wall here. In the background, we can see that the tank is at about 11 feet of leachate within the tank. Here's where they can load a truck from. And if we look at a different angle, we can see the truck can park in this area. And usually there's a sump within these truck pads. So if something spills out when they're transferring leachate from the tank to the truck, it can be caught and then pumped back into the tank. So in conclusion, landfills are designed to drain leachate to a sump or out to the facility's leachate collection tank. They're required to have a design of no more than 1 foot of head on the liner. Pumps remove leachate from the sumps. All these facilities should have high-level alarms that notify them when there is excess head on top of the sump itself. And leachate is sent from a tank, either being hauled off or directly to the sewer where it can go to a treatment plant. So Leanne, I can turn it back over to you to see if there are any questions out there now.
Okay. So it looks like we do have some questions. And the first one is coming from someone, it appears that they are an inspector. It says, a landfill I regulate uses a sand drainage layer instead of gravel drainage layer. In your example, the sand drainage layer had a lot of leachate buildup on the liner. How do I know that this is not the case for the landfill I regulate?
Okay, so you'd have to look at the design of the facility, and it's probably easiest to ask the Ohio EPA engineer that also regulates that facility to actually show you the HELT model and to walk you through how the landfill is actually designed. So the key aspect to whether sand or gravel needs to be used is really how far that leachate flows from the high point down to the leachate, down to the leachate pipe. And as long as that's a reasonably short distance, the sand would work. In the example I showed, it was a very long distance of about 650 feet. So if that's the long distance that it's flowing from the edge of the cell to the pipe, sand may be an issue, but if it's a really reasonably short distance, 150 feet or so, sand will work just fine. Okay, Leanne?
Okay, another one. One of your slides, you show a leachate pipe penetrating the HDPE liner. How do installers keep that from leaking?
It's a difficult thing to do. Generally, they're successful. Sometimes they're not, and they have to go back and fix it. But they put on a plastic boot. Looks kind of like a top hat if you think about it. So we have flaps going out to the side and then a round cylinder that actually gets welded to the pipe itself. And then the flaps off to the edge get welded to the liner system. They incorporate a copper wire in there. So once they put the plastic extrusion weld onto the cylindrical part of the top hat looking boot, then they can test to see if there's any spark going through that plastic. And if electricity can't get through the plastic through a hole, water certainly can't get through the plastic to leak. So that's a basic design of how it's done. as you can imagine, that's not a very easy thing to do. So most people aren't designing landfills that way these days. Yeah.
Okay. We have another one. What keeps the lift station that you were explaining from overflowing if the pumps stop working over the weekend when no one is around?
All right. So some of these lift stations have call boxes associated with them. So when that high level alarm goes off, the operator gets a phone call letting him know that that high level alarm is going off. If you have a facility with one of these lift stations, it's a good idea to ask the operator whether or not there's a call box associated with them that lets them know when the high level alarm is going off. If there isn't one, might be a good thing to encourage them to have. All right, any other questions, Leanne?
We have another one. Is there a trade standard for the number of sumps for the size of the phase that is draining?
A lot of design engineers try to base that off of each individual phase will have its own sump. Typically, that's the best design practice, but a lot of facilities drain larger areas to that, which contributes to problems when their pump goes off. You can imagine if a small area drains to a sump, the amount of potential leachate to come there at one time is reasonably small. The bigger the area gets, the more that pump has to pump out of there, and the more problems there can be if that pump breaks down. So it's a balancing act. You know, the more pumps you have, the more expensive it is, but the more pumps you have, the safer it is. So it's something that each designer has to decide on, and each owner operator has to design on. But the agency tends to encourage people to put in more sumps, more pumps than less.
Okay.
Leanne?
We have another one. It says, do most containment structures have plugs to drain?
So the secondary containment structures typically have a sump in them themselves that, you know, has a small sump pump in there, typically just like you'd have a sump pump in your basement, but an industrial type sump pump that pumps that rainwater or possibly leaking leachate back into the tank. So typically, instead of actually having a drain, they just have a pump that pumps it back into the tank. Leanne?
We have one more question, but this question will be answered in the next presentation, so I'm just going to move over this one, but I do not see any more, so we will get ready to transition to the next presentation. Thank you, Brian.
Thank you.
I just want to do a quick reminder, if you haven't already and you get a chance, send an email to me or Jeff Monavon. Our contact information is in the live Q&A, and just let us know you're attending and your RS number, or you can just send in a live Q&A for us and we'll get you marked. We will send out certificates within the next couple weeks. During presentations, please feel free to chat in your questions as you think of it, and we'll have it in the queue for our presenters. But now we will move on to our next presentation with Sarah Anderson, and it is on inspecting leachate collection systems. Sarah is one of our inspectors in our Southeast office in Logan as well. So Sarah, when you're ready.
So good morning. Brian, I think, presented some really great information about the engineering of leachate management systems. And now I want to talk a little bit about inspection best practices. Some of the information may seem a little bit repetitive, but you know, I'm coming at it from an inspector's perspective rather than an engineer's perspective. So let's go ahead and get started. So here is the administrative code rule that defines leachate in respect to solid waste. So you can easily see it's a pretty easy definition that leachate is any liquid that comes into contact with or has been released from solid waste. I'd argue that protection of the environment from leachate derived from the landfilling of solid waste is one of the key aspects to the design and engineering of modern solid waste landfills, and thusly is one of the most important parts of our municipal solid waste landfill inspections. So I remember the very first time I observed and smelled leachate. It really makes an impression. And while all leachate is not created equal, it's commonly dark in color and strong in odor. It's hard to miss. This is actually leachate that was released from a 3-acre open dump, and you can see the very dark color here. This is a leachate outbreak that was excavated on the slope of the landfill, a very large outbreak. And here you can actually see the bubbles of landfill gas that are coming up through this opening in the side of the landfill. Here's another look at leachate. Doing your homework is very important to conducting a thorough inspection of the leachate management system. While components of leachate management systems are often similar, each landfill is designed in a unique way. So knowing the number of sumps, the compliance points for a foot of head off the liner, the types of tank and conveyance system that are used at the landfill prior to your inspection is really helpful information. If you're a new inspector or new to a particular facility, it's a good idea to have a chat with your Ohio EPA inspector and or the engineer. Brian kind of talked a lot about that. It can also be helpful for you just to look through the permits to install, plan sheets, and any construction certifications. And of course, as you do that, you feel free to always reach out to us here at the agency if you have any questions. But those are all good things to do so you know what to expect when you're on site at the landfill. So here is the municipal solid waste landfill inspection checklist for inspectors. It's my hope that if you're responsible for inspecting a solid waste landfill, that you're utilizing this checklist. This is the top portion of it. This checklist may be used both for a comprehensive inspection or a focused inspection. It's a great tool to guide you while you're on site at the facility. Given the complexity of most MSW landfill operations and their compliance, the checklist really helps you ensure that nothing's missed during your inspection. If you're not currently using this checklist or you're using an older version of this checklist, there is actually, I've got a live link here. I don't know if they're going to actually send out a copy of the presentation, but this is a live link. If you don't use that link, you can always reach out to your Ohio EPA inspector. They can send you an electronic copy or send you the link online. This is housed at Ohio EPA's website. So an up-to-date version is always available on the website for you. So as I mentioned before, leachate management is a significant part of a comprehensive inspection. This is the primary section from page 2 of the inspection checklist, and this is kind of what we'll reference throughout the presentation. You'll notice here that there are rule references on the left, and they cover 2719 E1, which is construction, E11, which is inspection, and K, which is leachate management. So 2719 E1C requires the owner operator to maintain the integrity of engineered components at the landfill and to make any necessary repairs. A failure in and of itself is not necessarily a violation of this rule, but rather the failure to identify and properly repair the engineered component in a timely manner may be a violation. So when we talk about engineered components, particularly in regard to the leachate management system, these include those components described in the sanitary landfill construction rule, which is 2708. Notably, the rule requires that repairs must restore the system to the original design. And as we move through the presentation, I'm going to kind of show you some instances maybe where things weren't repaired to the original design as required. 2708 may not be a rule that inspectors reference every single day, but I encourage you to refresh your memory and take a look at the sections noted on this slide to ensure that you're hitting all the engineered components that are observable during an inspection. So let's talk about some of these components. Here's a list of common engineering components that you may observe at the facility. And I think Brian talked about pretty much all of these. So here's a list and we'll kind of go through them, and I'm going to show you some pictures of some really good setups and some setups that there were some issues with. So you can see in the circled area here that item 43 on the leachate management portion of the inspection checklist, this E1C reference, specifically asks about leachate sump and tank readings and whether or not they're within compliance limits. As you'll note as we go through this presentation, there's a number of other engineered components that are associated with the leachate management system. If there are any issues with those structures, you can use the check in the following section under ancillary structures and engineered components. So this is item 49. So if you note any issues with tanks, pumps, secondary containment structures, or leachate conveyance structures, you know, if any of those things are not functioning properly, you should make a note of their condition on page 4 of the inspection checklist in the item and information section. So here's a photo of a leachate lift station with the floats that Brian had the real dandy little animations that I really like. You can see here, you can very clearly see the second float that would turn on the pump. Here's the third float, as he indicated, that would turn on the high level alarm. And actually you can see the first float over here in the corner. You know, this is one of the definitely more simple systems, but you know, facilities do continue to use these. So you may see these at your landfill. This is where we move into a little more sophisticated systems. I find as landfills construct new cells, their technology tends to get a little more sophisticated each time. So this is a panel at a landfill sump, and the panels will often have the following components. And I'm going to kind of zoom in here so you can see those a little better. So they'll have a digital readout for the depth of the leachate in the sump. And this happens to be a sump with 2 pumps. So there's actually 2 readouts. There should be a switch for the leachate pump with an automatic and on and off setting. And you can see that here. Sometimes instead of on, it'll say hand. And that just means that you've turned it on by hand and it's continuously pumping. But the pump should be in the automatic setting at all times. There's usually an indicator light somewhere that the pump's on. So here on this panel, you can see these lights are where you would note if the pump was running at the time of the inspection. And then they're also required to have a high level alarm. And those are up here, these lights that would turn on should the sump reach a level that's above 1 foot of head on the liner. So this is where you're going to determine as an inspector how much leachate is in the sump at any given time. By knowing how much leachate's in the sump, you can determine how much head of leachate is on the liner at any given time. So Brian kind of went through this, but I really want to read the rule for you to kind of further clarify. So OAC Rule 3745-2708, which we'll remember is the construction rule C3I, states that the leachate collection and management system shall be designed to do the following, and it's limit the level of leachate in areas other than the sumps to a maximum of 1 foot throughout the operation and post-closure of the facility. For the purposes of the rule, a sump is an excavated depression of limited size that serves as a collection and transfer point for leachate. Therefore, a foot of head on the liner is the compliance point in this case. And Brian's, talked quite a bit about this. So I just want to talk a little bit about, how that's calculated and determined. So let's say at this particular facility, at this panel, the sump is 24 inches deep. So a foot of head on the liner would be 36 inches of leachate at the sump. And you know this because you did your research before the inspection. You know how deep the sump is. You may have confirmed it also with the facility representative when you're having a conversation during the inspection. So most facilities will have a high level alarm that's triggered at 36 inches. if that in fact is 1 foot of head at the liner. Brian also mentioned that some facilities will have their alarms go off, maybe a little bit lower than that, just so they don't ever go above 1 foot ahead. So for instance, at this facility, their high level alarm actually is triggered at 30 inches. So 6 inches below that compliance point. In general, the facility will tune the system so that it's in the automatic setting. When it's in the automatic setting, the pump will activate at some depth below the high level alarm threshold. In this case, we'll say that it's at 26 inches. The pump will automatically start and then proceed to pump the leachate out of the sump until some other predetermined depth, so say 12 inches, and then the pump's going to shut off. And it'll cycle through this, as that leachate recharges in the system to that sump. So it's not uncommon as an inspector to come to a panel and see the indicator for the pump isn't illuminated, you don't hear the pump running, and you don't see any motion on the digital readout. As long as the pump is on automatic and the leachate readout in this instance is less than 36 inches, the sump would be in compliance. So here's a closer shot of the digital readout. As you can see in this particular panel, they've actually labeled it to let you know that the leachate level is in inches. This is a very common digital readout that you'll see on lots of different panels. And they're, typically, unless, there's something kind of funny about it, they should be, this readout should be in inches. Just a word to the wise for inspectors, these digital readouts actually flash very quickly. So if you're trying to take a photo, sometimes you'll notice that it'll be blank in the photo, or not all the numbers will actually get captured. So you might have to take a couple pictures. I recommend utilizing the leachate sumps reading section on page 2 of the inspection checklist. This gives you a space to actually take notes. You can list the sumps, note if they were in compliance, record the reading at the time of the inspection, and there's also a checkbox to ensure that it was in the automatic mode. If you have a large landfill that has more than 6 sumps, we can kind of tweak these inspection checklists, so you can just reach out to your inspector from Ohio EPA and they can help you do that. So Brian talked about the transducer or the transmitter. This is a picture of them. You'll see it's just kind of a little bullet on the end of a very long cord. This is placed alongside the pump to measure the leachate level at the sump, and then it communicates that data to the panel, to that digital readout that we just saw. The transducers measure the pressure generated by gravity acting on the surrounding leachate. So that's how they get the reading that's then communicated to the panel. So here you saw on the panel a few previous slides that there were 2 digital readouts indicating that there were 2 pumps at the sump. And here you'll notice that this is actually for that same panel, and these are the 2 risers that go down into the sump itself, and that's where they place the pumps and the transducers. That's how they place the pumps and transducers into the sump. And these little white capped pipes here are actually clean outs. So this is another thing that you might see sometimes at the leachate sumps. This is just a flow meter for the pump itself. And I think in newer systems, oftentimes these tend to be a little more typical. So here's a really fancy sump panel. This is a pretty new panel at a landfill. And what you can see in here that's a little different than what we've seen in the previous electronic panels is all of the wiring here and here. This panel has telemetry. And telemetry is just the process of recording and transmitting the readings of an instrument to another system, typically a computer system, sometimes a call system. Brian sort of mentioned that about dealing with high-level alarms on the weekends. In this case, this is a very sophisticated system that you don't see frequently because it is pretty expensive, but it's kind of a top of the line system. So here, one way to know if you have telemetry at your panels, oftentimes the telltale sign is this tower, which is the communication back to the computer that's in this case in their offices. And here you can see this is a big screen TV in their conference room at this particular landfill facility that is hooked up to a computer. And this gives real-time data on all of the sumps at the facility. They're labeled here as LSR 05. There's 6 sumps that are noted on this panel. The facility is in construction and just had constructed a new cell, and there's a new sump which is not set up to read out on this panel quite yet. But you can see for each one, there's 2 pumps at each sump. It gives the real-time levels. It also shows, this is a system that has 2 leachate tanks, and it shows the levels in both of those leachate tanks. There's also some under drain setups, and here are some lift stations that are also, you can see the depths of the leachate at those lift stations, which is typically in a lift station, those are often places where leachate from other parts of the leachate management system that aren't the landfill come to, so they don't have that same typically compliance point. So oftentimes you'll see a higher level of leachate in inches in those types of systems. So this is sort of the creme de la creme of leachate management systems. So now that we've seen what well-maintained and functional panels look like, I want to take a look at a panel with some problems. Here you'll notice that the pump switch, it's kind of hard to tell, but this one is actually set to hand, so it's on. It is not automatic. So that's our number 1 issue. Another major issue you'll see is that the digital readout has quadruple 9s here. And in this instance, what had happened was there had been a large systemic failure of the leachate management system in this landfill. And the reason it was reading all 9s was because the level of the leachate at this sump was in excess of what the transducer was able to read. So we weren't even able to get an accurate reading because there was so much leachate being stored in this landfill at this time. You also notice that, when we talk about the design of systems, this panel obviously was not designed to be operated by a wrench. And when you see this type of thing happening in a landfill, you want to really start asking some questions about the integrity of the engineered components and how well they're being maintained, because obviously this was not how the system was designed. So let's move on to talking about tanks a little bit. As Brian stated, most facilities are going to have a leachate tank to store leachate outside of the landfill before it's either conveyed to a tanker truck or the sanitary sewer for disposal. Both of those, obviously go to a wastewater treatment plant. As Brian noted, leachate tanks can be single or double walled. As required from 08, any leachate containment has to be at least 110% of the tank or tank's volumes. So here's just a simple system with the concrete secondary containment. Here's another example. I kind of like this one because I think this leachate tank, to me, when you look at it from the outside, looks like a 2-tiered cake. It seems like, oh, that's a really interesting kind of tank. But when you look inside, you note that that bottom layer of the cake is actually the secondary containment for the leachate tank. Here's another example of a leachate tank. This is actually this is one tank of a 2-tank system, and here you can see the secondary containment has vertical concrete walls. You can see in the foreground here some of the conveyance structures that are housed in the secondary containment. And this is actually a system where you walk down steps into the secondary containment. Here, this is actually at a closed landfill, but it's probably the best example that I had of an underground leachate tank. The leachate tank in this instance is actually underground over in this area. This is the leachate tank riser, where leachate is removed. You can see here, this is the leachate loadout secondary containment, and it has a drain that flows back into this riser. And on the next picture, you can kind of see this is the riser itself. Once you open the manhole and look down in, this is the pipe that is the outflow from the leachate tank itself. And this is the outflow from the secondary containment of the leachate loadout system. So that's kind of a different look at one of those underground tanks. So we're going to start talking about some problems potentially with leachate tanks. If you'll notice here, if you look very closely at the photo, you'll see these ripples in the water. And that's not water, actually. This is actually all leachate that's in the secondary containment. And what you can't see very well is that up here, one of these bolts is leaking. And leachate is collecting in the secondary containment. So the secondary containment is functioning the way it should be. This is a wide view of that same tank, and you'll notice that there's a pretty good amount of leachate in the secondary containment. And in this particular instance at this facility, there had just been a cascade of failures in the engineered components of the leachate tanks and the leachate tank and all of its conveyances. And the reason that this leachate was pooling in the secondary containment was because the sump, which is somewhere in this area, which is just, when you talk about a sump, Brian talked about a little bit, it's just a low hole in the secondary containment. The pump in there had failed. So it was unable to pump that leachate back into the tank. So there were quite a few problems here. This is a leachate tank pump panel. So you're going to look as an inspector at a lot of panels, and they're all a little bit differently, but once again, they should, they basically have the same compliance points. Here, you'll note that while this panel was operational when I took the picture, the digital readout didn't come out. You'll notice that the loadout pump is on auto and that the sump pump is on auto. So those are things that you want to see. This system actually also has an aerator, but they were not utilizing that at the time of my inspection. Here is another leachate tank pump panel. And you can see here, this is a little more sophisticated. This is because this is a 2-pump system. And this is part of the system that we saw before. There's also telemetry here. So this was communicating back to that big screen TV in the conference room. Once again, you can see that the pump is in auto, the alarm is on. So those are all good things. So even though this is set up to telemetry, there's still physical alarms that go off here. And so here's a leachate tank pump panel at that same system where there's so many problems. And you'll note here that the alarm is off and that the pump is on hand again. So this system is not set up. This system is not being operated in compliance at the time of that inspection. Same system with all the problems. This is the this pump here was the pump that conveyed leachate from the tank into the loadout for the system. So this pump was not operational, so they had actually just placed this blue hose that you see in the foreground up into the tank, and we're pumping straight from the tank through this hose down to the secondary containment, which obviously was not how the system was designed and is not protective in the same way as the system was designed. So there were compliance issues here. As I discussed kind of early on in the system, what we saw in this system is during a subsequent inspection, the owner or operator, rather than replace the pump as they should have, just simply piped, added pipe to bypass the pump and added a lever here. So they just manually were turning on, opening this valve and using a pump down at the loadouts pad to pump leachate from the tank. This constituted, this obviously wasn't the original design of this system, so this constituted an unapproved, alteration modification to the system. And here they did finally fix it, and you can see the new pump installed. So this system then was, had been restored to the system as designed. So here's a secondary containment sump pump. This is the pump that had malfunctioned in the previous photos where leachate was pooling. But in all of these concrete secondary containments, as Brian said, there is going to be some sort of sump typically that just pumps any leachate and often any stormwater that gets into the secondary containment. If you have a heavy rain event, once it goes into that secondary containment, typically then it's just pumped back into the leachate tank and disposed. So here is a 2-tank system, and in the foreground you can see the leachate loadout. This is another panel system for a leachate loadout, so this is a pretty sophisticated system. Here, this is also a relatively very new system. Here's another leachate loadout. You can see this also is a 2-tank system, and you can see the conveyance, and it's actually the trucks parked in the secondary containment area, this loadout area, and they're removing leachate from the tanks in this system. Here's another example of a pump flow meter. This is actually at a leachate pump, and that allows you to assess the flow that's coming out of the tank. Here we've got another problem, same system. This is the secondary containment. This is leachate that's been pooled there. The problem once again is there was a sump here that's meant to pump the leachate out of this secondary containment back to the tank, and that pump had failed as well. So there's some pretty easy to tell that there's some issues. You can also see this is a temporary portable pump and another portable pump that they were using to pull leachate from the tank and put it into tanker trucks. This is just an example of a new kind of shiny pump. This is what they put into that secondary containment to alleviate the problems of that old pump. Here's just an example of some leachate conveyance. You can see we've got, the valve here to turn leachate on and off at this loadout area. Here's another example of loadout conveyance. I show you all these pictures just to kind of show how different every single system is. And so, if you're an inspector who only gets to inspect one landfill, you kind of have an idea of what your system looks like, but there are all kinds of variations on how these systems are designed and constructed. So here's just one other little thing. If you see this, once again, we've got a pair of pliers here. Anytime you see electrical tape or duct tape, it may be indicative that there's been some sort of repair that doesn't meet the design standards. So, this was a failure of an engineered component here. And here it is restored to as designed. And these red levers you'll often see as part of the leachate conveyance systems. So that kind of takes us through some of the different engineered components. So let's talk about E11A. So this rule requires owners and operators to inspect daily for a number of things. And one of those things is leachate outbreaks. Each day, leachate outbreaks, if they exist on the landfill cap, they need to be identified and work needs to take place to remedy the outbreak. And those should be noted, that work should be noted in the daily log of operations on Form 3. In addition, a daily inspection of the integrity of the engineered components is also required, and there any malfunction should also be noted. Here's the Form 3 for, this is the operator's daily inspection checklist. So leachate outbreaks and any corrective actions should be noted in the corrective actions taken and other comment section, as well as any failure of any engineering components. Unfortunately, this section as it stands in this current form is impossibly small, so it really doesn't it doesn't speak to how important really this section is. And I think because it's small, it's often underutilized by operators. When I talk about the Form 3, I like to explain to facility owners and operators that this particular section is super important, and it's their opportunity to show me as the inspector what's going on at the facility and what they've done to address it on any given day. Because as you've seen as we move through this presentation, a failure or a leachate outbreak isn't a violation in and of itself. It's failure to address those outbreaks or violations. So here is the owner operator's place to show how they've addressed those things. And because it's only one line, I often encourage operators to add an additional page or use the back to give yourself more space to talk about what you've done on any given day. Because there are a lot of other things that certainly can be noted in this section as well, outside of just leachate outbreaks and engineering components. So sometimes we have to get a little creative with space and how we, the technical assistance we give to operators in completing this form. So this is 2719 K1. This covers leachate outbreaks. Once again, the leachate outbreak is not the violation. It's failure to contain and properly manage it. And that's one of the major compliance points. And depending on the frequency of outbreaks at a facility, it may be necessary for the owner or operator to devise like a more robust recording system for keeping track of the management of these outbreaks. Some facilities, may not have any outbreaks, and some may just have a few, but at times there are facilities that have quite a few outbreaks. So you want to talk about, you may need to kind of help them figure out a system that works for them in order to properly identify and track those. If you do have a facility that consistently has a lot of leachate outbreaks, you do want to kind of take a look at C and really evaluate if the landfill itself, if the operator is taking enough action to minimize and control and eliminate the conditions, which contribute to the production of leachate and often contribute to the leachate outbreaks at a facility. So here's some pictures of some leachate outbreaks. You can see the telltale color here, and I don't know if it's readily apparent, but it's running down the slope. This is down slope here, and it's running down the slope, pooling here, and then it continues to run here. Now, in this instance, the facility had dug out an area here with the hopes of this draining, but unfortunately, they still had failed at this point to properly manage and contain this leachate outbreak. Here's another example. You can see these orange flags. So the facility has identified the leachate outbreak. It actually starts up here, and oftentimes you want to look closely where you see dead vegetation, because that can be indicative of a leachate outbreak that's running down the slope. So the outbreak actually starts up here, and they've once again dug out an area to drain that. You can see, the really dark color here of the leachate. Here's another example. This is a leachate outbreak that had not been identified or contained at the time of the inspection, and you can see it kind of coming down the hill here. This is a particularly interesting situation. This was kind of the toe of this landfill. This is an actively kind of the active part of the landfill that was moving down into an unconstructed area. And if you look closely, you can see the leachate running down this outbreak out the side of the slope, and it's pooling down here. What's particularly problematic about this leachate outbreak, and of course why we have concerns about leachate outbreaks in general, is this is an unconstructed cell of the landfill. And so we have leachate out here that is mixing with surface water that's outside of the leachate management system altogether. And so, this is, potentially, contaminating both surface water and the groundwater in this area since it's outside of the liner system. So K2 just requires the owner operator to maintain a backup pump. As you can see in the systems that have 2 pumps that are already in each sump, the second pump kind of acts as a backup. So those systems are meeting that rule. If you have systems where you just have 1 riser and 1 pump, there actually should be a physical backup pump on a shelf somewhere at the facility, ready to be put into use if a pump fails. So that's usually a question that you'll have to ask your operator, and oftentimes have to have them show you, because lots of times those are going to be in a maintenance office or somewhere, that may be outside of where you typically inspect, during your inspection. So this is K5, and this is the rule that talks about treatment and disposal of leachate. As I said before, and as Brian mentioned, leachate's typically transported to a wastewater treatment plant by a tanker, or it's directly conveyed by a sanitary sewer that's either directly plumbed to the leachate management system or plumbed to a leachate tank. There are some facilities that pre-treat their leachate in order to meet disposal criteria of their wastewater treatment plant where they take leachate. Special note here, leachate recirculation. I think while it's not a common practice any longer, some facilities do still have leachate recirculation approvals. If the facility has such an approval, they're required to keep additional documentation, and that's something that you want to review as part of your inspection. So while it's not required as part of the daily log of operations, facilities are required to calculate their monthly leachate disposal totals and submit those as part of the annual report. So it might be helpful for you to review the annual report numbers prior to your inspection to get a sense of how much leachate is being disposed on a monthly basis, and therefore, thereby it tells us essentially how much leachate is being generated in most instances. While you're on site, you can also request to see disposal receipts, or oftentimes facilities will have logs or spreadsheets that show how much leachate they're either trucking out every day or how much leachate is going to the sanitary sewer each day. And I think it's a good idea to take a look at those at each of your comprehensive inspections. Just some additional considerations that aren't part of this rule, but kind of piggyback off that idea. The annual report, that's where they're required to do, to report those leachate numbers. They're also required to report the location where the leachate was treated and disposed. And they're also required to verify that the leachate management system is operating in accordance with this rule. As part of the annual report, they're required to do an annual leachate sample. That's a grab sample, and they test them for the parameters that are part of Appendix 1 of 2710, which is the groundwater rules. And then each year they're required, as part of the annual report, to provide a summary of any maintenance that was performed on the leachate management system, and also to attest to whether the leachate management system was tested for clogging or damage. And there's a couple of different ways to do that, but typically leachate management systems are jetted, and to make sure that all of that piping system is still intact and operating as it should. And that's all of the underground systems that we can't see as inspectors. So you want to be aware that they're doing that, and you can certainly ask those questions to the operator while you're doing your inspection. So that's pretty much it for me as far as my presentation. So I'll let Leanne take back over and maybe answer some questions.
Okay, we do have a few questions that have come in. The first question is, do you ever conduct an inspection where everything is functioning well with the leachate management system?
Yeah, so that's always my hope and dream is I go out on an inspection and there's no violations. And certainly, you know, sure, there are times when you go out and do an inspection and everything's working great. I just accompanied the health department yesterday on an inspection, and, you know, their leachate management system was, you know, really functional and they didn't have any issues. So yes, you absolutely can. And I think sometimes as a new inspector, or maybe if you're new to a facility, you might feel a little bit, you know, like you have to find something wrong, but certainly there are lots of facilities that operate that are doing everything that they should. And as I said before, even if they have leachate outbreaks, or even if something's broken that day, as long as they're addressing those situations, you know, they're still in compliance.
Okay, we have another one. How do you know if the facility is properly managing leachate outbreaks?
So the first step is that you want to know that they've been identified in some way. So if you're out doing your inspection and you come upon a leachate outbreak, and I showed you some pictures where it's very clear that you see nothing around that's marking that, you see that there's been no work done. You looked at and one of the ways you can tell is you can go back and look at the daily log of operation from the day before. You know, most of the time when you're actively seeing leachate like that, it's not brand new. So you can look at the daily log of operations at Form 3 and see if that leachate outbreak has been identified on that form, or if there's any physical identification of the outbreak out on the hill. And then, you know, that's part and parcel to having conversations with your operator as far as, you know, when you're on your inspection. But those outbreaks should be noted on that Form 3 in some fashion. So that's kind of how you know whether or not they've been identified, and then you can talk to the operator about, you know, if it doesn't appear that any work's been done, you know, what's your plan to alleviate this outbreak?
Okay. The next question is, how do you know if a high-level alarm is functional?
So in the basic systems on those panels, typically there's a test button, and you can just have the operator, when you're looking at each of the sump panels through your inspection, do that test alarm. And in fact, I was on an inspection a couple of days ago where I had the operator do that, and one was working and the other wasn't. So they then knew that, you know, that light maybe was out and that needed to be fixed. So there is a test button on most of those systems. And I always make sure to I don't ever touch anything when I'm doing an inspection. I always make sure to have the operator do it, because I certainly don't ever want to be responsible for breaking something. So you always want to make sure you have the operator flip those switches to test those alarms.
Okay. Another question is the orange colored liquid flowing from a landfill usually considered to be leachate?
Yeah, so you know, when it looks like a duck and quacks like a duck, it's probably leachate. If it's actually coming from the surface of the landfill itself, yes, it's probably leachate. You get into some gray areas sometimes when you start finding leachate that has migrated off of the landfill itself. And in those instances, when leachate is migrated outside of the footprint of its landfill itself, you know, you can still, I think, be fairly certain that it's leachate if, you know, by the coloring and the smell. But at that point, sometimes, you know, testing may be necessary to confirm that it is in fact leachate. And that's certainly something that if you have those concerns, that you can partner with Ohio EPA and we can work together as a team to bring in our Division of Surface Water folks and you know, make that happen.
Okay. The next question is allowable feet of head different between solid waste landfills and a CNDD landfill?
You know, that's a good question, and maybe Brian can answer that, because I don't know off the top of my head the rules on CNDD landfills and their leachate management system.
Yeah, I believe it's off the top of the liner for C&D and off the top of the sump for landfills, but I can quick double check, and after the questions I can answer it for certain.
Yeah, we can definitely get you that answer. That's no problem.
Okay. I am not seeing any more questions for you. Thank you for your presentation, Sarah. And we are going to move to our third presentation today. It will conclude our workshop. It's a presentation on landfill leachate and pretreatment from the Division of Surface Waters, Phoebe Lowe. It is a recorded presentation. Phoebe was not able to join us today. That also means we're not going to be able to answer any questions related to it. However, we can always help you get an answer. If you do have a question, it'll just be at a later date. So Jeff, when you're ready, we can have Phoebe's presentation play.
Most of you are probably more involved with DIMWIM than with DSW. So I'm going to do a quick summary of some of the division's focus areas and how they differ. First, we have DIMWIM, which focuses on how landfills are constructed, operated, and managed. Second, we have DDAGW, which focuses on protecting sources of drinking water and groundwater. And third is my division, DSW. In relation to landfill leachate, DSW strives to protect surface waters. Although DAGW and DSW both focus on water, surface water and groundwater are different. This slide accentuates the difference between DDAGW and DSW, where groundwater is below the Earth's surface. Surface water is located above the Earth's surface and includes rivers, lakes, and wetlands. What is leachate? Leachate is defined as liquid that has come in contact with or been released from solid waste. So let's back up a bit here. Just to recap, solid waste comes in and is essentially buried into these compartments called cells. These cells aren't just some hole in the ground. They include a barrier designed to hold in any waste, solid or liquid, from contaminating the groundwater below. One of the common ways that leachate can be generated is through precipitation events. Rainwater seeping into the cell becomes contaminated. If the clay and plastic liners are doing their jobs, the liquid will accumulate within the cell. Besides precipitation, there are many other factors that impact leachate production. Another common one includes the chemical and biological reactions that can occur within the solid waste itself. The accumulated leachate is pumped out of the cell and typically undergoes treatment before it is discharged into a water body. But why does it have to be treated? And how and where is it treated? So why treat leachate? Let's take a look at what's even in landfill leachate. For one thing, it is high in organic and inorganic pollutants. Another is that the pollutant levels are highly variable and depends not just on the waste characteristics, but also environmental factors such as climate. Let's compare leachate to domestic wastewater. For the purpose of this presentation, domestic wastewater, or residential wastewater, refers to the wastewater generated in our day-to-day household use. Note how the typical leachate is significantly more polluted than the wastewater that leaves our households. Okay, so we've established that the leachate definitely has to be treated before it goes to any stream, river, or lake. After collecting the leachate, who treats it? The three most common options include treating it on site, meaning that the landfill has an effective treatment system on the property. Due to unavailability of space or funds, many landfills may rely on other options. These options include off-site treatment, which means that the landfill sends the leachate elsewhere for treatment. Basically, once that other facility receives the leachate, it is out of the landfill's hands. The third option is a combination of on-site and off-site handling. The landfill could have a system that partially treats the wastewater before sending it elsewhere to complete the treatment requirements. For this presentation, we'll be focusing on the off-site handling and the mix of both. But when it gets off-site, where does it actually go? Usually, the leachate is sent to a wastewater treatment plant. Out of the nearly 40 active facilities that hold a municipal solid waste landfill permit, a majority of these send their leachate to a wastewater treatment plant. So what is a wastewater treatment plant? It's a facility capable of treating wastewater down to levels appropriate for discharging to surface waters, such as rivers, lakes, streams, etc. Note that most of the wastewater treatment plants accepting leachate are designed to mainly treat domestic wastewater. For example, as you'll see in the scenario below, wastewater from domestic uses enter the wastewater treatment plant. The water is polluted, but the wastewater treatment plant treats it down to levels that are acceptable and safe for surface waters. The wastewater treatment plant discharges the treated wastewater to the surface water. So how does leachate even get to a wastewater treatment plant? Leachate can be transported to a wastewater treatment plant through a direct connection or by hauling it to the wastewater treatment plant. Now, you might be wondering why any landfill would want to haul its leachate instead of use a direct connection. A landfill would have to haul leachate if it's physically far from the destination or if the nearby wastewater treatment plant cannot accept the leachate. A landfill hauling by truck is always on the lookout for other wastewater treatment plants that are closer. But whatever happens, the landfill should have a second option for leachate disposal at all times. If the wastewater treatment plant turns them away, they need a backup plan. But why would a wastewater treatment plant reject leachate? Well, let's explain how the leachate could impact a wastewater treatment plant. Remember how I said that the wastewater treatment plants are mainly designed to handle domestic wastewater? Well, here's that side-by-side comparison of leachate and domestic wastewater again. If a facility typically experiences domestic wastewater, it's easy to see how leachate can overwhelm the treatment system if given in high enough volumes. In a previous slide, we went over an example of how domestic wastewater is treated at the wastewater treatment plant. Now we'll try the same scenario with leachate. Again, domestic wastewater enters the wastewater treatment plant and takes up some of the plant's capacity. When we add leachate into the mix, we see that it takes up even more capacity, but it's still operational. The pollutant levels start off high as a result. The wastewater treatment process occurs, bringing the pollutant levels down to an acceptable level for the river. The treated wastewater is then discharged into the river. Because the pollutant levels are low enough, the river is not significantly damaged and the fish are fine. Now let's see a scenario of where things could go wrong. We start off the same, where the domestic wastewater enters the wastewater treatment plant and takes up some capacity. When the leachate is added, it pushes the total incoming wastewater to go over the capacity that the plant is designed to take in. As a result, the pollutant levels start off very high and do not get treated down to a level safe for the river. This wastewater ultimately enters the river, and the pollutant levels have affected the river to the point where the aquatic organisms are harmed. Well, what if the landfill wants to try the third option, which is treating it partially before sending it to the wastewater treatment plant? How does that work? This is called pretreatment, a process that reduces or removes pollutants in the wastewater before it is sent to the wastewater treatment plant. As we can see in the simplified scenario below, the leachate's pollutant levels are very high and has the potential to cause problems at the wastewater treatment plant. Now let's try another scenario, only this time the leachate goes through a pretreatment system. This pretreatment system reduces the pollutant levels so that it is more manageable for the wastewater treatment plant to handle. Note that there is no law that states that every landfill must have a leachate pretreatment system. The necessity for such a system is determined on a case-by-case basis. To summarize, leachate is a liquid that has come into contact with landfill wastes. Landfill leachate is most commonly sent to a wastewater treatment plant for treatment and discharged to surface waters. However, there are other options, such as treating and disposing the leachate through on-site systems. Remember that DSW's focus is on protecting surface waters. We discussed in the previous slides how the leachate has potential to impact watersheds. Because these sources of pollution have potential to impact surface waters, Ohio EPA issues permits to these facilities to ensure compliance with surface water regulations. In regards to permits, please contact me if all of the following apply. The landfill is sending its leachate to the wastewater treatment plant, and more than 25,000 gallons of leachate is sent to the wastewater treatment plant each day, and the landfill does not have any permit authorizing it to send its leachate to this specific wastewater treatment plant. This means that 1, DSW did not issue an indirect discharge permit to it, and 2, the wastewater treatment plant did not give them a permit either. If all of these criteria are true for the leachate disposal, then this landfill may need an indirect discharge permit to be able to continue sending its leachate to the wastewater treatment plant. Now, if you wanted to find a list of indirect discharge permits, you can find it on Ohio EPA's website. Note that these permits are sorted by districts. Just for clarification, when I'm talking about this 25,000 gallon threshold, I'm talking about the amount of leachate that's typically discharged for a single day of hauling or discharging to the wastewater treatment plant. For example, a landfill leachate has reported disposing 5 million gallons of leachate in 1 year. They have also reported that they have hauled their wastewater 120 days over the past year, and that their leachate has always gone to the same wastewater treatment plant. If you divide 5 million gallons by 365 days, you determine that the average discharge is about 13,700 gallons a day. Because this is less than the 25,000 gallon threshold that we discussed earlier, we can also assume that no indirect discharge permit is needed. However, this is the wrong solution because it factors in the total days in a year, 365, not the days in which the landfill has hauled its wastewater to the plant, which is 120 days. If you recalculate the leachate flow using the number of discharge days, you will get 42,000 gallons per day, which is a huge difference compared to the incorrect method above. Because the discharge flow rate exceeds 25,000 gallons per day, this landfill may actually need an indirect discharge permit after all. In addition to the list of indirect discharge permits, other resources on Ohio EPA's website include the annual operational report and daily log forms. Each municipal landfill submits this report every year around March, and it reflects the previous calendar year. Contents include the volume of leachate generated, how the leachate was treated and disposed, as well as leachate sampling results. This report is available through Ohio EPA's eDocs website. For the purposes of simplifying your search query, I have included some useful tips. The red boxes indicate specific fields that narrow your search down to the annual operational reports. The green boxes indicate the most useful fields to narrow your search down to a specific site or time frame. Sometimes you could get a long list of operational reports. From my experience, the reports dated around March is usually the correct one. What are you looking for specifically? Well, to give you an idea, here's a picture of the first page of the 2019 annual report form. The blank form itself is 28 pages, so there's a lot of information in a report submitted by a landfill. You'll know that you're on the right track if your eDocs search brings up a pretty large file, roughly 75 to 100 pages long. Fortunately, leachate is only a small part of this report. You will find the volume and disposal methods summarized in section 14 of the operational report. It should have a similar layout to this example, where the volume and destination of leachate is broken down by months. Leachate sampling results are located in section 15 of the report. This includes nearly 100 parameters, which include metals, inorganics, organics, and PCBs. These leachate sampling results are collected as a grab sample from the landfill management system. Let's also talk about daily log forms. Landfills are required by law to maintain a record of its daily log of operations. You can find a copy of this form on Ohio EPA's website. From my understanding, the landfills do not necessarily have to use this exact form, but whatever records they use must include all the information required by law. Leachate regulations and requirements are actually outlined on page 3 of this daily log form template. I'll just give you a second to look over some of these rule references and write them down if you need to. And that's the end of my presentation. Does anyone have any questions? If you would like to ask questions privately, please feel free to contact me. Thank you very much.
Okay, so that was the last presentation we have for the Ohio EPA and OEHA Leachate Management Workshop. We appreciate everyone who took the time out of their morning to come join us, listen to these presentations. Thank you to Sarah and Brian who are with us for their presentations. Thank you to Jeff who had all the behind the scenes things going so we could have this presentation today. If you guys have questions, please always feel free to reach out to us. If you have suggestions for another workshop, we would love to hear that. We're always looking for ideas. If you did not get a chance to let us know you were here and you'd like to, just in case, your name didn't get registered when you logged in, maybe you had to log in anonymously, please do that with either the Q&A or sending us a quick email. We always appreciate it. This was approved for 2 RS credits. We are going to submit this sign-in sheet that will be created from the logins in our emails and the chats to ODH within the next week. We will also get certificates out to everyone. So again, thank you very much, and we appreciate you joining us.